So the question by now is, how do you know which hybrid orbital you need? And it turns out there's a very easy way to figure it out. And you can just look at Vesper and look at the number of repulsions. And if you've got two repulsions and you ask yourself, well, what's the geometry here? The geometry, according to Vesper, right, is linear, and you've got the 180-degree angle. And then the type of hybrid orbitals you need are P. So 1 part S to 1 part P. So totally awesome, right? And if you got three repulsions, then according to Vesper, right, you've got that trigonal planar 120-degree angles, and the type of hybrid orbitals you need there are sp2. So remember, you're taking 1 part S and 2 parts P here, whereas here you're taking 1 part S and 1 part P. And of course, you've got 2 other P orbitals that are unhybridized here. Here you've got 1 other P orbital that's unhybridized. And if we go on down to 4 repulsions, then that is that famous tetrahedral geometry, that 109.5 degrees. And here's where you need sp3. So you can see there's a very nice, easy pattern here. So the number of repulsions gives you the number of hybrid orbitals. So you need 2 repulsions, you need sp. 3 repulsions, you need sp2. 4 repulsions, you need sp3. So remember, right, when you hybridize one s with one p, you get an sp and another sp. That is to say, the number of atomic orbitals you bring into the mix gives you the number of hybrid orbitals. So if you've got an s orbital and a p orbital, you get 2 sp hybrids. If you got an s orbital, a p orbital, and a second p orbital, that's 3 atomic orbitals, so you get 3 hybrid orbitals. And the same for sp3. If you take 1 s and 3 p's, that gives you 4 sp3 hybrids. And again, they've got that geometry there. So the sp hybrids, right, they point at that 180 degrees. So there's an sp and there's an sp, and they got little tails. Sometimes we draw them in, sometimes we don't. So there's the one, there's the second one. sp2, right, you've got that trigonal planar, so that 120 degree kind of arrangement, and those orbitals basically move on the same direction there as my bonds I've drawn. So those are my sp2, so 1, 2, 3. And if I look at sp3 hybrids, right, so that's that tetrahedral. So I need something that's going to have that tetrahedral geometry. So my sp3 hybrids basically point along the bonds, right, in a tetrahedron. So there's my first, second, third, and fourth. And there's a couple more hybrid orbitals. So if you got 5 repulsions and 6 repulsions, so 5 is that trigonal bipyramidal. So you've got, well, let's see, it's 90 degrees and it's 120 degrees, right? So you got 2 different bonds in there. And the type of hybrid orbitals you use here are actually sp3d. So why is it sp3d? Well, you need to have 5 orbitals. So this is the trigonal bipyramidal. Okay, so you need to have 5 orbitals, and of course if you got an s orbital and all the p orbitals available in a valence shell, it's only 4, so you need a 5th one, a d orbital, to blend them together. And so that gives you these sp3d hybrids, and again they point 1 up, 1 down, and so that's the axis, and then 3 along the equator, so 1 here, 1 here, and 1 here. So you've got the 2 axial ones, and you got the 3 equatorial ones there, and those are your sp3d hybrids. And for 6, right, so 6 is that, let's see, octahedral, and I guess they're all 90 degrees, apart from the ones that are opposite each other that I guess are technically 180. So you need 6 hybrid orbitals here, so you need 6 atomic orbitals, so you got an s and 3 p's, that's 4 of them, so you need 2 more to blend together. So you just go ahead and grab a couple of d orbitals. And if we go ahead and we try and draw that, so it's kind of funky. So there's 1, there's 2, and there's 3, there's 4, there's 5, there's 6. And so when you blend them together, essentially now you've just got a lobe, you've just got an orbital pointing along each one of those 6 axes like so. So isn't that awesome?